Hello and welcome back. So today we are going to talk about the top 3 currencies that we are using in the world. What has this got to do with logarithms? Okay, so remember I talk about base currencies, right? So we talk about Singapore dollars and Malaysian ringgit. So you might want to think about, okay, if you kind of fix currencies, different countries use different currencies. Maybe there's like what are the top 3 most popular currencies that people use around the world? So what I have here is the top 3 most popular currencies. Number 1 is US dollars, right? I'm sure most of you know what US dollars are because it's just popular, right? And also, fun fact, you can use US dollars outside of the United States. For example, in Vietnam, you can actually pay for things using US dollars and receive change in US dollars instead of the official currency, which is the Vietnamese dong, I think. Not too sure, right? Let me know if I got it wrong. Number 2 is the euro. It's used by 19 countries in the European continent. That is popular, right? Like 19 countries, wow. And you have the Japanese yen, which is also quite popular, but I don't know where else you can use the Japanese yen. Okay, so of course, then we're going to talk about the different bases that are really popular that when we talk about logarithms. Okay, so number 1, not that it's the most popular, but I just want to let you know one of the popular bases that we like to use is 2, log base 2, binary for life. Okay, so who or what group of people, if the US people from United States use the US dollar, then who uses log base 2, right? So it turns out computer scientists, computer engineers, programmers, software developers, people like that, they like to use, people doing with a lot of computers, right? They use log base 2 precisely because of binary for life, because binary is a system that counts up to 2, and so everything is in base 2, and of course you use log base 2. We'll go through some examples of questions in base 2. It's going to be fun, watch out for that. Next, we have another popular base, which is base 10, and I think it's quite intuitive why 10 is one of the popular bases, because number 1, we have 10 fingers. Number 2, we are comfortable with powers of 10, tens, hundreds, thousands, 10,000s, millions, billions, right? Or if I ask you to multiply certain numbers like 23,512, multiply that by 8, you might take a while or punch that in the calculator and give an answer. But take the same number, 23,512, multiply it by 10. You can tell me the answer instantly, right? That is 235,120. I think so, right? Okay, so that is base 10. This is commonly used because this also has another name. It's called common log. Log base 10 is commonly used by scientists. Okay, so we'll also look at some of the applications, some examples of log base 10 questions that we apply in real life. Okay, so also watch out for that. And lastly, but not the least, is natural log. And some of you might have already learned this in school. You know what the base is, but every time students always have a lot of question marks on their head. When we say natural log is log base this number, and then you'll be like, what? How is this even natural? Okay, so I'm going to try to convince you, but try doesn't mean that you'll be convinced. Okay, I hope you'll be convinced by some of the examples. Okay, so let me just tell you, the natural log is log base e. E can be found on your calculator. Right, so if you press e to the power of 1 and you press equals, you get 2.718281828. Your calculator will probably stop somewhere around here, 10 or 11 digits, but I can go on a bit further. Okay, and if the decimals continue, they don't really repeat, so this is an irrational number. And be like, what? Why is this natural, right? This is not natural. I would say 10 is more natural than this. Okay, so let me give you some examples on why we call it natural. Yeah? Okay, so if you look at this one over here, this sum, when I'm adding fractions, adding and subtracting fractions. Okay, 1 over 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 plus 1 over 5. So it's like a plus, then you minus, you plus, then you minus, then you keep increasing the denominator by 1. Okay, by the way, all these numbers, the denominators 1, 2, 3, 4, 5, are what we call natural numbers. Okay, so these are natural numbers, right? Alternating in the denominator, well, alternating signs, and then you increasing in the denominator. The answer to this, right, is natural log 2. Okay, by the way, this dot 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 means that you carry on forever, right? You use all the natural numbers, which nobody knows when it ends. It just goes on infinitely. Yeah, this will get you natural log of 2. Like, how does that happen, right? But yeah, that's why it's natural log. Okay, another thing that you might be interested in is, again, same thing, but without the plus and minus. It's just all pluses now. Okay, and we know that if we plus all the way infinitely, it's not a meaningful result. It's going to go towards infinity. But if we add it up to some number n, okay, then this answer will roughly be natural log of your last denominator, okay, plus a certain constant, yeah, which I will not discuss over here. But hey, natural log, yeah, gives you answer to problems with natural numbers. Yeah, so I find this really, really fascinating, and that's why I think I like mathematics. But anyway, that's the end of today's video. I just want to introduce to you the different types of popular bases that we use logarithms with. So watch out for the next few videos where we look at examples of log base 2, log base 10, and last but not least, log base e, natural log. So catch you in the next one.